Lesson 4, Review of Arithmetic. We already started some of this yesterday, so I'm just going to run through the first things pretty quickly and then continue. Numbers and numerals. Remember, numbers are these abstract quantities that we can't see. Sometimes referred to as ideas, but they are things that exist, but we can't see them. What we can see are the numerals, the words or symbols used to represent them. Whenever we have a numeral, we want to be aware that it has a value, which is the number that it represents. You can have many different numerals that represent the same number, that is that they have the same value. So for example, 2, positive 2, 2.0, 4 over 2, those are all different numerals that have the same value. We talked about natural numbers or counting numbers. We can use to count things that we can see. The technical definition is that these are positive integers, so they don't have a fractional part, they don't have a decimal part, and they're all greater than 0. Real numbers are any kind of numbers that we're going to be talking about this year. If you can describe a physical distance, whether that distance is in front of you, positive, behind you, negative, or at the same location as you, 0, that's a real number. The other kinds of numbers that aren't real are called imaginary, and we're not going to worry about them this year. Any real number can be represented on the number line, which as you see here has 0 in the middle, and it goes forever in both directions. There are arrows at each end of it. As we go to the right, our numbers get larger, and as we go to the left, they get smaller. In order to graph a number on the number line, that means that we'll draw a point where it is. So for example, if I were to graph negative 1.5 or negative 1.5, I would draw a dot here and label it. When we have two numbers that are opposites, for example 3 and negative 3, those are the same distance from 0, just in opposite directions. So for example, if something were 3 feet away from you, it could be 3 feet away in front of you or 3 feet behind you. Same distance from 0, but opposite directions. Multiplying fractions. When we multiply fractions, unlike adding or subtracting, we do not need a common denominator. We're just going to multiply across the top and multiply across the bottom, as we see here. So 4/3 times 7 over 5. Notice that these are both improper fractions. That doesn't matter. Multiply across the top, 4 times 7, and across the bottom, 3 times 5. And we get 28 over 15. If you want to, you can simplify that into a mixed number, because it's an improper fraction, 1 and 13 over 15. Or for my class, you can just leave it as an improper fraction. That's fine. Always make sure to simplify. Usually when there's simplification to be done, well, really always, you can do it before you multiply, but doing it after it is fine also. So here with 13 over 15, that can't be reduced at all, but here let's look at one that will involve some canceling. So here we have 3/5 times 5/6 times 21 over 23. Now when you see a problem like this, you really want to make sure that you're looking for things to cancel out ahead of time, because otherwise we're going to be multiplying 3 times 5 times 21 on the top and 5 times 6 times 23 on the bottom. We're going to end up with large numbers, and arithmetic is going to be difficult, and we're going to be more likely to make mistakes. So let's see here. Remember that fractions, this indicates division, dividing by the thing on the bottom. So if we're multiplying by 5 up here, for example, and dividing by 5 down here, those will cancel out. So we can cross out those 5s. We're dividing each of them by 5, and we get 1. Similarly, 3 and 6, we can divide both of those by 3. When we divide 3 by 3, it becomes 1, and when we divide 6 by 3, it becomes 2. So we end up, instead of having this original problem, we have 1 over 1 times 1 over 2 times 21 over 23. And now we multiply across the top and get 21, multiply across the bottom and get 46. A lot easier in terms of the arithmetic, and also we don't have to go and figure out if there's any simplification left to do here. When we divide fractions, we're going to keep, change, flip. The first fraction will stay the same, that's keep. The second thing that happens, the change, is division will change to multiplication, and the second fraction will flip. The bottom will become the top, and vice versa. Then we just treat it like multiplication of fractions. So for example, 4/3 divided by 15 over 8. Keep the 4/3, change division to multiplication, and then 15 over 8 becomes 8 over 15. Then we'll just multiply across the top, 32, and multiply across the bottom, 45. No simplification to be done there. Let's take a look at one that involves mixed numbers. Whenever we have mixed numbers that we're multiplying or dividing, we want to treat them like fractions, and in order to do that, we're going to need to convert them to improper fractions. So 12 and 1/3 becomes 37 over 3. 3 times 12 is 36, plus 1 gives us 37 over 3. And 2 and 1/6, 6 times 2 is 12, plus 1 is 13, so 13 over 6. Now we've got division of two fractions. Keep the 37 over 3, change division to multiplication, and flip 13 over 6, and it becomes 6 over 13. Now we can simplify. 37 is prime, and so is 13, but 3 and 6 can both be divided by 3, so we'll divide them each by 3. 3 becomes 1, 6 becomes 2, 37 times 2 on the top, 74, 1 times 13 on the bottom, 13. Since 13 is prime and it doesn't go into 74, we know that we don't have any simplification left to do. Equality and inequality. When we use an equal sign that indicates that two things have equal value, remember there are multiple ways that we can represent the same value in math. As a simple example, 2 plus 5 equals 7. That equal sign there means this thing that we've written over here has the same value, namely 7, as this thing over here on the right. When two things are not equal, we'll use the not equal sign, which is the same but with a slash in it. So 2 plus 5, that is not equal to 11, because the value of this is 7 and the value of this is 11. Our four basic operations, as a reminder: addition, when we add two things together, that's called a sum. Also, if we add 0 to anything, we get the same number. If you have $10 and I give you 0, you still have $10. The inverse or opposite of addition is subtraction, and there we call it a difference. Be careful, remember that with addition and subtraction, addition can be done in any order, but subtraction you have to do left to right. Multiplication, we multiply two factors together and get a product. In order to get any number to produce itself again, we multiply by 1. Any number times 1 is the same thing. 14 times 1 is 14. What we can also do here is we can multiply any number by 0, and then we get 0. If each bag has 14 potato chips in it, and you have 0 bags, well, then you have 0 potato chips. Division, the inverse operation of multiplication. Here our result is called a quotient. Make sure you know these terms: sum, difference, product, and quotient. When we're using decimals, be careful when you're adding or subtracting to line up the decimal points. They should be one right above the other to make sure all your places are lined up. When we're multiplying, we'll multiply just like multiplying multiple digit numbers, and then at the end, count the total number of digits after the decimal points in the numbers that you're multiplying, and then go down to your answer and place the decimal point such that your answer has the same number after the decimal point as the original two did combined. And when you're dividing, we don't want to divide something with a decimal part by something else with a decimal part. We want to get rid of the decimal part in the divisor, the number that we're dividing by. So we'll move the decimal points in both of them over until only the dividend, only the thing that goes inside the box or on top of the fraction, only that one has anything after the decimal point. And we move them each the same number of spaces in the same direction. Unit multipliers. This is the most difficult and the newest topic in this unit. Some of you may have done it before. When we have measurements from the real world, whether they're measurements of length or time or distance or volume, we have a number of different systems that we can use to represent these. For example, we could measure a distance in feet or in inches or in miles. So how are we going to change it from one to the other if our original distance is in feet, for example, but we actually want the number in inches? We can do this by keeping in mind that multiplying by 1 will always keep the value the same. We want to keep that distance that we're measuring the same, and we can do that by multiplying by 1 to change the appearance of it, change the form of it. We're going to change the numeral, but not change the number. We're going to do this by multiplying by fractions. I'll show you an example in a moment, make this a little bit clearer. But when we're multiplying by these fractions, we have to make sure that each one we use is equal to 1, namely that it has the same value on the top as the bottom, that the top and the bottom are equal, so that the fraction as a whole is equal to 1. So for example, if we want to convert 32 feet into inches, the way that we set this up is first we write 32 feet as an improper fraction, as 32 over 1. Notice we write the feet there, make sure you keep your unit here. Now what we're going to do is multiply it by a unit converter, which is equal to 1, to change it. We want to get rid of the feet here. Whatever unit is here that you're trying to get rid of, you'll put on the bottom of your unit conversion fraction. And whatever unit you're trying to change it to, in this case inches, we'll put on the top. So since we're getting rid of feet, we put feet on the bottom. We had feet up on top, feet on the bottom now. And we want to change 2 inches, so inches go on the top. Now, in order to make these inches and feet equal to each other, well, we know that 12 inches are in 1 foot, so we write 12 inches over 1 foot. This is equal to 1. 12 inches and 1 foot are the same distance. We're always allowed to multiply by 1 because it's not going to change the value. Then when we multiply, these units will actually cancel out. We have feet on the top and feet on the bottom, and we'll cancel those out, and we're left with 32 times 12 inches. Notice the inches stay there. They didn't get canceled out. And we're just ignoring the 1 times 1 on the bottom, because anything over 1, we can just ignore the over 1 on the bottom. Let's do a more complicated example. Convert 10 meters to inches. Now here, we don't have an easy conversion between meters and inches. What we're going to have to do is start with meters. We'll change it to centimeters first, and then we'll change the centimeters into inches, because meters to centimeters is a standard conversion, and so is centimeters to inches. So the way we'll do is we'll start out by writing 10 meters over 1, just writing it as a fraction over 1. Then we're going to multiply it by 1 twice to do the unit conversion. One time to change it from meters to centimeters, and then another time to change it from centimeters to inches. So the first time we do this, we're trying to get rid of meters, so we put meters on the bottom. We're trying to change it to centimeters, so centimeters go on the top. How many centimeters and how many meters will make this balanced, make it equal to 1? 100 centimeters are in 1 meter. Then, after we've done that, we'll need to change it from centimeters into inches. Since we're getting rid of centimeters, we put centimeters on the bottom of our new fraction. And since we're going 2 inches, we put inches on the top. Then we make it balanced. How many inches go to how many centimeters? 1 inch goes to 2.54 centimeters. Once we have this set up like this, then we can cancel out and combine. So meters up top here and meters down here, those cancel out. Centimeters up top here, centimeters down here, those cancel out. The only unit we have left is inches, which is what we're trying to get to. Now we can just multiply them like any other fractions, 10 times 100 on top, and 1 times 1 times 2.54 on the bottom, so just 2.54. Notice with these unit conversion problems, you don't need to do the arithmetic. You can leave them like this, and that makes it very clear that you set it up correctly, and at that point it's just an arithmetic problem. Here are the unit conversions you need to be familiar with. 1 foot is 12 inches, 1 yard is 3 feet, 1 mile is 5,280 feet, 1 inch is 2.54 centimeters, 1 meter is 100 centimeters, a centimeter is 10 millimeters, and 1 kilometer is 1,000 meters. If you don't know any of those unit conversions, make sure you learn them now because they will come up on the homeworks and the tests.